Good evening, America. This is ENGR 122-003 reporting live. My name is Daniel Johnston. I'm joined by my colleague Anosh Bartala and our wonderful cameraman Troy Griffin. There have been new reports, new stories coming in recently about the toy from Hasbro, the Bop It. The technology is out there and the people are begging the question, what's next? Where's the Bop It going to go from here? Are there any new designs on the horizon? And we are happy to announce there are indeed. Just last week, the engineering team, the Blanket Statement, came out with its newest design product, the Flip It. As you may well know, the Bop It uses fine motor function and fast reaction timing to engage children. And the Blanket Statement has taken it a step further with the addition of the accelerometer in its newest product. Made to the likeness of the Bop It, this is the final design that the Blanket Statement has developed. Here we have a working prototype with all of the main features of the Flip It, and I'm going to turn it over to my colleague Anosh.
So they have keep it very simple. So now I'm going to talk about the components used in the Bop It. Here we have 3 push button switches which work as a Bop It, pull it, and twist it. And beside that we have a piezo speaker for the speaker purposes, and we have a accelerometer and a gyroscope which help to measure the 3-axis rotation of the devices, which can help to figure out if the device is flipping or not. It's powered by a 9-volt battery pack which contains a 6 battery. For the coding, they have keep it very simple. We have a function called random analog which is going to generate a random number, and for the coding over here we have 4 random number, 2, 3, 4, and a flip it feature. Each of this button is associated with a specific number. For example, this button is associated with 2, 3, and 4, and we have another feature of flip it. And for the flip it feature, the accelerometer gonna measure the flip it feature each time if the device is flipped. And we have a piezo speaker that is gonna make a sound if the correct button is pressed, or make a sound which is the wrong sound, if the user prompt a wrong button.
I'd like to briefly go over the hardware features that we have inside this final design. Of course, for the Bop It, we have a 120 push button switch here. The engineering team created this clever design of mechanical arms that could, or I suppose levers, that are able to pull on these 220 switches. Here for the pull it, we have this one 220 push button switch that is pulled by this mechanical arm. And if you go over here, you may not be able to see it that well, but for the twist it, we have another arm going laterally while the 2 push button switches go vertically up like this. And as the arm twists, it pushes the buttons down one way or the other. Before giving a demonstration of how this game is played, I'd like to go briefly over the sound system that you're about to hear. For 1 short beep, it will be this button to be pressed. For 2 short beeps, this button. For 3, either of these 2 buttons can be pressed, and for the long tone, the entire device will be flipped one way or another along the Z-axis. Without further ado, the quick demonstration. And I've lost. And that is a simple demonstration of how the game is played. This video was filmed on Louisiana Tech Campus in the spring quarter of the year 2025. The disciplines used in this project were mostly electrical, while there were some elements of mechanical and cyber engineering.